All right, let's take a picture. Let's take a look at this picture that's up on the board, and let's look at our learning target. It says I can use my knowledge of area and perimeter to solve a constructive response. Remember in math, when we do constructive responses, it involves some work and a little bit of writing. Our constructive response is long, though. No, they're not going to be long. So it might just be you do a couple steps to solve the problem, and then you might use 1 or 2 sentences to explain how you got your answer. Does that make sense?
Yes.
All right, so let's look at this picture. Inside of my square, what does that say? So by definition, the space that is inside of a figure is called the area. All right, so let's look at what is the word that's all around a figure. What's the word that is around this figure? Diana? Perimeter. So by definition, the perimeter is the length that is around the figure. So does everyone see how the picture matches the definition? Okay, do you have any questions on that? All right, so your piece of paper that you have should be broken up into 4 pieces or 4 boxes, correct? In your upper left, you should have part A. In your upper right, you should have part B. In your lower right, you should have part C. And in your lower left, you should have part D. So this way, as we are going through this constructed response, we're going to start and end in a circle. Does everyone see that? Okay, you do not need to write that arrow. It's just so that you understand the flow of which things are going. Understood? All right. Let's take it one step at a time. All right, it says Mason used 4 rectangular pieces of wood to make the slide for his brother. Use these pieces to answer the question. So I broke it up. Each question is on its own slide. Okay? So part A, it says, what is the difference in square inches in the areas of the top of base of piece B and the top of piece C? And we always have to show our work, obviously. So which 2 figures are we going to be using here? Which 2 figures are we going to be using here? Are we using everything? No. Keep in mind, I always told you that when you do get a math problem, sometimes they give you the extra information that you don't really need. Do you? Okay, so what is one thing that we can, or that I can cross off on my picture easily so I know, okay, I'm not using this? What is one thing that I can cross off? Yana? I'm crossing something off because I'm not using it. And in the question it's asking is the area of part B and part C. So do I need those? Yes, I do. So what is one thing I don't need? A is something that I do not need in this part. What is another piece that I don't need because I'm not using it based off of this question? Devaney? D. I am not using D. So the only ones that I'm using here is figure B and figure C. Okay, so now with area, remind me what area is. Are we doing multiplication? Are we using addition? Are we using subtraction? Or are we using division here for area? Sean? Diana, want to help him out? We're using multiplication. So with area, we need to remember that it's always length times width. Let's say that again. Area equals length times width. So we need to remember that, okay, throughout this entire part. Understood? All right, so let's extend this page. And so for us to figure this out, we're going to have to do multiple things here, okay? So we first need to know the area of piece B. Make sense? Okay. All right, so in order for us to do that, we know that B is going to equal which 2 numbers so that I can multiply? Natalia? Speak up. Okay, 36. There it is. We got to speak completely. So we're going to do 36 times 36. Do you know your 36 times tables? Does Miss Jenkins expect you to know your 36 times tables? No. Okay, so think about the steps in which we are going to need in order for us to answer this question. Okay, what about C? What about C? What would my formula or my equation be for C if I'm working with the dimensions that are given to me for my picture C? Santiago?
48
Mm-hmm.
times 36.
Exactly. 48 times 36. All right, we're going to have to do some math here. So for this type of problem, am I making a bar or am I drawing a window? Why am I drawing a window? What is the reason as to why I need to draw a window here? Catalina?
Because 48 and 36 are two different numbers.
Correct. 48 and 36 or 36 and 36 are two-digit numbers. Okay? So let's work with B first, all right? So what you're going to do is, in your part A, we are going to show what we did for B. So please write B equals 36 times 36 in your part A box. Okay? So you told me I need to draw a window. Once I drew my window, what do I need to be doing here? Someone help me out. What do I need to be doing? Devaney?
You do 36 on top.
Okay, so how do I show 36 on top? Devaney? 30 plus 6, because we are breaking 36 down by its place value positions. There is a 3 in the 10, so that value is 30. There is a 6 in the 1, so that value is 6. It's just like how if you have 6 $1 bills, you have $6. But if you have 3 $10 bills, is that $3? How much is that, Becca? It's $30. Does everyone see that? Okay, so what belongs over here? Michelle? 30 plus the 6. And don't forget to have your multiplication symbol. Alright, so I'm going to go out of order to fill these boxes. What two numbers am I using here to fill in this box right here? Nehemiah? This box? 6. Right. Okay, so do you know your 30 times tables? No. So what numbers am I really working with to help me solve this problem? Kenny? 6 times 3. And what is 6 times 3? Okay. So he said that 6 times 3 is 18. So in this box, I do the 6 times the 3, which is the 18. Am I done filling in this box? What am I missing here, Angel? And how many zeros do I need to add? Just one. Because there is 1 0 here, so I need to have 1 0 in my answer. Okay. What would be the answer for this box? Jordan? 180. Is he correct?
Yes.
It's the same thing. This box was the 30 times the 6, but this box is also the 30 times the 6, so make it easy for you. How do I fill in this box? What two numbers am I working with here to fill in this box right here? Michelle? 6 times the 6, and what is 6 times 6? Courtney?
36.
36. So to always track our thinking, we have it all to the side. All right, what goes in here? Nicolette. 900. And Nicolette, can you please explain to us how you figured that out?
I figured it out by doing 3 times 3
Mhm.
equals 9.
Mm-hmm.
And then you add the 2 zeros.
Correct. There's 1 0 here, there's 1 0 here. Now I have a question. What do I do with these 4 numbers that are on the inside of my box? What do I do with those 4 numbers that are on the inside of my box? Yana? You gotta add them. Okay? So in my inside of the box, I have 900. I have 180. I have another 180, and then I have 36. When I add my ones, what do I get? Natalia? 6. What is 0 plus 8? 8 plus 8? writing 19 of underneath here. Well, what do I do? Down here. I put the 9 down here and I do what with the 1? Yes, I put the 1 up and over the 9 in the hundreds position. Good job. All right, 9 plus 1?
10.
Plus another 1.
11.
What do I do with that extra 1 just chilling up top? So I'm left with 11 plus 1, which is 12. Can someone say this number properly? Michelle,
1,296.
did you say it right?
Yes.
That's what I'm hearing. Make sure you have your comma there, okay? Alright, we gotta go back up to the top to show this one. Am I creating another window? Alright. Walk me through it. I don't know what I'm doing. I did my windows. What can go up top here? What can go up top here? Michelle? 40 plus 8. What can go up top here? 70. 30 plus 6. All right. Let's fill in this first one. Anaya?
1,200.
She said 1,000. Oops. She said 1,200. Anaya, can you explain loud and clear what that means?
I did 4 times 3,
Mm-hmm.
and I added 2 zeros.
Okay, so she knew that 4 times 3 was the 12, and we have 2 zeros here, so we need to have 2 zeros in our answer. What goes here? What goes here? Dayana? 240. Explain that.
I know that 8 times 3 equals 24, and I added my extra 0.
She added her extra 0. And she said she knew that 8 times 3 is 24. She needs to add the extra 0 because there's a 0 in 30. What goes here? Courtney?
40 times 6,
Okay, so what is that?
240.
240. Can someone explain how she got that answer, Jordan? Mm-hmm. Correct. I have a 4 here. I have a 0 here, so I need to bring down another 0. What goes here? Catalina.
48.
48. This is just a regular math fact that you should know. So she knows that 8 times 6 is 48. Again, class, what do I do with these 4 numbers on the inside, everyone? So let's get to adding. Alright, so I have 1,200. I have 240. I have another 240, and then I have a 48. When I add my ones, what do I get, Michelle? 8. What's 0 plus 4?
4.
Plus another 4.
8.
Plus another 4.
12.
So I put my 2 down here, and I carry my 1 up and over to the hundreds? Alright. 2 plus 2.
4.
Plus another 2.
6.
What do I do with that extra 1?
7.
What does it become?
7.
Good job. What do I do with the 1?
Bring it down.
Bring it down. Okay, so now I know that the area of B, everyone see that? Is 1,296 inches squared. I know that my area of C is 1,728 inches squared. But my question asked us the difference. The question asked us the difference. What do we do here? If it's asking us the difference, what do I do with those 2 numbers? if it says the difference. Yana? Yes, in a way we are comparing, but we want to know the difference between the two numbers. What does the word difference mean, Sean? We need to subtract. Okay, when we do a subtraction problem, when I do a subtraction problem, what number comes first? Is it the bigger number or the larger number? What number always has to come first in order for you to properly subtract? Anaya? The larger number. So this means we take we take 1,728 and we subtract 1,296 from it. So Yana, when you said we compare the numbers, we have to compare the numbers in order to set it up, correct? All right, in order for us to compare the numbers, we need to figure out which number was larger and which number was smaller. When we compare the numbers, we read them just like how we read from left to right. So could we compare the numbers just from the thousands position? No, because they're the same value. 1 is not greater than 1. Then we go over to the hundreds position. 7 is greater than 2. Because the 7 in the hundreds place is greater than 2 in this hundreds place, we know that 1,728 is greater than 1,296. Okay, someone come up to the board and do this subtraction. Nikolai. Is she wrong if she put that 0 there? No. I mark her wrong. What is the 0 actually? Yeah. It's just a simple placeholder. Okay, does everyone see that? Alright, if I have 8, I do have enough to give you 6. So that's why I have 2 left over. However, if I have 2, can I give you 9? If I have 2 holes, can I give you 9? No, I cannot. So with that being said, I have to borrow from the hundreds. When we borrow, how much do we borrow? We borrow what to give what? Yana? We give 10, so we have to borrow how many from this one? We borrow 1 to give 10. So the 2 now became a 12. 12 minus 9 is 3. And then when we borrowed from the hundreds place, this 100 or the 7 became a 6. And 6 minus 2 is 4. Does everyone see that? Yes, Sarah? Say that again. You put it in what? Okay, so I need an answer statement here. The question is asking is what is the difference between the area of part B, of piece C and piece B. So what should my answer statement be here? Anaya?
The difference between part B and part C is 432.
432 what?
Square inches.
There it is, okay? So in your answer statement, what you need to have is, you would say the difference, just like she said. Between part C and B is 432 square inches, period. So not only did we show our work, because this is a word problem, we always have to have some kind of answer statement that goes with it. Okay? So this type of problem in this part alone was 3 different steps. We had to figure out the area of piece B. Then we had the second step was to figure out the area of piece C. And then once we do that, we had to do some subtraction and then give it an answer statement. And now when you guys get into the 5th grade next year, you're going to have problems just like this, but they're going to be more complicated. Which is why I'm always telling you, learn your math facts. Because they're going to expect you to know your multiplication facts and your division facts for 5th grade. Sure, they'll still might quiz you on your math facts, but they expect you to know them already going into the 5th grade. Because a lot of the things that you're learning in the 5th grade, you're going to have to be able to kind of use your knowledge of 4th grade. So when we were going into fractions earlier in the school year, and I kept telling you, learn your math facts, learn your math facts. And then when we started multiplying with fractions, a lot of you were like, oh, I see why. Does everyone understand what I'm saying?
Yes.
So please make sure that whenever your teacher is writing something on the board, make sure you're writing it down. If you're not understanding something, make sure you're asking your questions. And try your best to follow along. I know it's not easy sometimes, because sometimes you sit there and you get tired. Your teachers get tired too. But please make sure that you are writing everything down. Understood?
Yes.
Do you have any questions on what it is we did here? So when you're working with the word problem, you have to first understand what the information is that you really need, that you'll be using. On top of that, you'll have to figure out what operation or what steps you're taking here. Because if we notice, the first thing that we noticed was that I didn't even need piece A or piece D in this problem, did I? It just gave you extra information. So you first need to decide what information you need. You need to decide the steps you need to take. You need to solve it. And then when you're done with everything, make sure you're checking it. Understood? Do you have any questions? How do we feel about this problem? If you feel good about it, give me a 5. If you feel, give me a 4. If you think you need a little bit more practice, give me a 3. If you were like, Ms. Jenkins, I don't really know, give me a 2. And if you're like, Ms. Jenkins, I don't know what you did on that board, give me a 1. Thank you for your honesty. Some of you were like 4. I have a 1 or 2 3s. That's okay. And you might, what it really is that you might have gotten lost with the multiplication part, which some of you already know. We're not the best at with our multiplication facts. That's why I was constantly quizzing you throughout the school year, right? Understood? And then also on top of that, a lot of you understand that multi-step problems can be very confusing. So did we rush through this problem?
No.
We took our time through it, right? So that's the important part. A lot of you, when you get a word problem in front of you, you read it once, and then you get to work. You had to tell me what information we needed to use, right? And then you needed to tell me what steps we had to take. So that's why when you do get word problems in the future, please make sure you are taking those first 2 steps seriously. Decide what information you need to use, and then decide what steps you're going to take. Because in each part of a constructed response, it's not always going to be the same. And I'm going to show you with part B. All right? Just follow along with part B. All right, with part B, it says to keep the slide from moving, Mason put a piece of rubber around the perimeter of piece A. What information do I not need here, based off of my question? What information do I not need that I can start crossing off? Devaney? Okay, so I don't need piece B. What's another piece of information that I don't need? Ephraim? C, I don't need it. Last one, I don't need. Yana? D. So they try to do this on purpose, and I'm not going to lie. Teachers give you problems like this on purpose to see if you're really paying attention. Because right off the bat, I don't need any of those three. The only one that I need here is A. Now, look at the question one more time. It's asking about perimeter. This is different from area. Area we multiplied, but perimeter we needed to do what? What do we need to do for perimeter? Nehemiah? We have to add. So here is a different step. So again, we first figured out what information we needed. And our second step was we figured out what steps we needed to take to solve it. Our third step would just to be simply solve it. Now with perimeter. Am I just adding the 60 and the 36 and then calling it a day? I cannot forget that there's another side of this figure. What is the value of this length right here? Efren? It's 60. Opposite sides of a rectangle are equal. This is a rectangle. Does everyone see that? So the opposite side, which is this part, is going to be 60. So that means this side right here is what, Michelle? 36. Now can I properly solve this problem? And when I properly solve this problem, what numbers am I working with here? What numbers am I working with here to add the perimeter? Well, okay, so I need to do 60. What else? 70. 36. When I add this, what do I get? Same hands. I need different hands, Jordan.
You get 96.
I get 96. Am I done here? No, I used this 60. I used this 36. But I need to take it a step further, correct? I have a question. If I were to add this over here, what am I going to get when I use this 36 and 60 over here? What am I going to get? Nicolette? 96. So I found my totals, but what do I need to do with these two 96s to find the entire perimeter? Nehemiah? We need to add both of the 96. And what is 96 plus 96? Someone walk me through this problem. Kenny. We're adding 2. Take it step by step. Tell me what I need to do first. Tell me what do I need to do first. Which is 12. So I put my 2 down here and I carry my 1 up and over to the 10s. 9 plus 9 is? What do I do with that extra 1? Add it. So I get 192 just like you said. But my final answer would be 192 inches. That's it. I showed my work, gave my answer, and because we are working with measurement, we always have to have a unit here. Does everyone see that? Do you have any questions here? It's kind of straightforward because it's adding, right? All right, this one here talks about using the wood and then figuring out how much money we are spending. Okay, so Mason bought 48 square feet of wood, and the price for $1 is every 4 square feet of wood. What is the total cost? So if I have a total of 48, but each 4 is $1. What am I doing? I have a total of 48, but each 4 square feet is $1. So what am I doing with these numbers? Anaya, we're dividing. Now what numbers am I dividing? Natalia?
48
48
and 4.
and 4. Does everyone see that? Okay. So I have to break down 48 into groups of 4 to figure out how much money I am spending. Does anyone know what that is off the bat? Because this is a division fact, which is also a multiplication fact. Yana? Give her a round of applause. Oh! Yes! It is, because she knows that 4 times 12 equals. Okay, so do we have to really set up our division problem and do all of that? No, this type of problem, I told you, if you know a multiplication fact, do you need to waste your time showing all of that work by drawing boxes, filling it in, then adding it all up and doing all that goodness? No, don't do that. She knew off the top of her head. So what you can do is show that by saying, I know that 12 times 4 is 48. So I know that I would be spending $12 because 48 divided by 4 is 12. Does everyone see that? She didn't have to do nothing magical. She knew off of the top of her head. So we will be spending $12. Does everyone see that? All right, you have $20. I spent $12. How much money do I have left over? I said, Jordan, go to the store. I'm giving you $20. You come back to me and you say, Miss J, I spent $12. What is the change that he is going to give me back? Carolina, $8. Look at this picture. You have to buy a can of paint, and you have to buy a paintbrush. You have to buy 1 can of paint, and you have to buy a paintbrush. And the amount needs to total up to $8. I'll say it one more time. You have to buy a can of paint here. And you have to buy a paintbrush. What would you choose? And it has to equal $8. Efren?
The small paintbrush is the medium can.
Okay, so he's saying the smallest paintbrush, which is $1, and the medium-sized can, which is $7. Is he correct?
Yes.
Because 7 plus 1 is 3. I have another question. Is that the only answer here?
No.
I got it.
Nehemiah? So he's saying buy the smallest paint can plus the medium-sized paintbrush. The smallest can is $6, but the medium-sized paintbrush is $2. Is he wrong? Okay, so if I were to be grading this, and Nehemiah said the small can and the medium paintbrush, and Ephraim says the medium can with the small paintbrush, can I mark either of them wrong? No, because what was the requirement? They had to spend how much? $8. Did they both spend $8? So as long as they show their work to prove that they spent $8, can Ms. Jenkins mark either of them wrong? No. Who thought of the small can and the medium-sized paintbrush at first? All right, put your hands down. So that means the rest of you were probably thinking the medium can and the small paintbrush? Some of you, I know that there's a few of you that probably would have wrote down both, right? But I'm only asking for one way. This question only asks for one way. And you would have to explain your choice. Yes, Yana?
Can 8 times 1 equal 8?
Yes, but here we're adding it because we want the total amount. That is good. What you just said there is, that is perfect, that you're thinking that way. However, again, we want the total amount of money. So yes, 8 times the 1 gives me the 8, but I'm looking for the total amount. So I needed to buy 1 can and 1 brush. Yes? Well, yes, that'll still be 8. However, I want total. Total means what word?
Adding.
Adding. You gotta add, you gotta use some kind of addition here. Does that make sense? Do you have any questions on how we solve a 4-part problem like this? That was a lot to take in, I know. It was a lot. But does everyone understand how we're using what information is given to us and how we use it? That's something that we have to get better with as a class. And sometimes I quickly look at a math problem because I had to solve these problems before I even gave them to you. And I quickly looked at the math problem and I saw Efren's way at first, but then I looked at it again and I was like, wait a minute, there's another way to solve this part of the problem. Does that make sense? And the moment I said there's another way to solve this problem, more than half of you raised your hand because you were able to see the different types of combinations. Okay? Good job, boys and girls. Give yourself a round of applause. All right, my back row and middle row, you can take your colored pencils and put them back.